Hey everybody, I want to show you how to solve a quadratic by completing the square. Now for a lot of people this is the hardest method, but I will say as a math teacher it's probably one of the most important because it's sort of how you prove all the other methods. But first I want to kind of explain what I mean by completing the square. So if I gave you the number 23, and I said I want 23 to be a perfect square. Now what do I mean by perfect square? A perfect square is a number like 4, so let me write that down here, 4, 9, 16, 25, and so on and so forth. Now the reason these are perfect squares is because 2 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25 is 5 squared, and I think you get the point. But notice 23 is not a perfect square because it's not some number squared. But if I wanted to, let's say, complete the square, I would, let's say, add 2 to this. Because if I add 2 to this, I get 25, which is then a perfect square. And that's kind of what we're going to be doing, but instead of finding a number, so 25 is what we call a perfect square, because again you can represent it as some integer squared. What we're going to be doing is creating what's called a perfect square polynomial. So I'll even write that down here, a perfect square, sorry about that, square polynomial. And remember what a polynomial is. Polynomial is just an algebraic expression which has terms separated by addition and subtraction. So you know the x squared plus 6x minus 3 up here is a polynomial. So a perfect square polynomial, what that is, so just to relate it back to over here, a perfect square is a number that can be represented as some number squared. A perfect square polynomial would be a polynomial that can be represented as some binomial squared. So something like this. And this may not make sense right now, but once we get to doing this problem, it'll hopefully make a little bit more sense. Okay, so in starting with this problem up here, the first thing you want to do if you're completing the square, or solving by completing the square, is you want to get your constant over to the other side. So I'm going to move the 3. So that's your first step. And I'm going to leave a little space here, and you'll see why in just a minute. So x squared plus 6x, and I'm not going to put anything, I'm going to leave a little blank here, equals 3. So all I've done so far is just move that number to the other side. Now to complete the square, so again over here I completed the square by adding 2. To complete the square over here, I'm going to take this 6, divide it by 2, which gives me 3, and then I'm going to square that number. So we always take this number next to x, we divide it by 2 and then square it, and that tells me what I need to add to complete the square. So 3 squared is 9. Now because I have an equation here, I can't just add 9 here, I have to also add it over here. So remember, if we do it to one side, we have to do it to the other. And again, I apologize, for some reason my computer is being very glitchy, so I'm having to deal with that. Okay, so now some of you may be thinking, okay, that's nice, but how is that completing the square? Now the reason this is completing the square, and I'm gonna come over here and erase real quick, maybe give myself some more room. And just to reiterate what I did here, let's use a different color. No. So all I did was I took this number 6, I divided it by 2, which is 3, and then squared that number, which is 9. Now this right here can be written as this: x plus 3 all squared. And then equals, of course, 3 plus 9 is 12. So now, this part here is what makes it completing the square. So when I took 6 and divided by 2 and squared that number to get 9, I completed the square so that it would be represented as some binomial squared. Now, just to prove it to you, I'm gonna come over here and just prove it to you. And again, this is not, the things I'm doing right here are not something you have to do, but I do want to show you again where it comes from. Because if you're anything like me, I understand something when I understand why it works, not just how it works. So I'm gonna come over here, again, just kind of separate this for me. If I do x plus 3, so remember, x plus 3 squared, what that means is x plus 3 times x plus 3. Oops, I don't need that, sorry. Now I'm going to distribute this. I'm going to do this fairly quickly. So x times x is x squared. So I'm just distributing this here. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. Now if I combine like terms, I get x squared plus 6x, oops, plus 9. Now if you'll notice, what I've just gotten here is the same thing as this over here. So what I've done when I added 9 to both sides is I made this polynomial a perfect square. And again, what I mean by that is it's some binomial, and remember binomial just means it has two terms. It's some binomial squared. And some may be asking, well, how did I know it was x plus 3? The way you know is whatever you get when you divide that middle term by 2. So when I did 6 divided by 2, I got 3. Whatever that is, that's what goes here. So if there was a 10 here and it was 10 divided by 2, that'd be 5. So then you'd put plus 5 here. And I'm going to do another example. I'm already at 7.5 minutes here, so I can't finish it in this video, but I will do another video doing another example because I know it's kind of convoluted right now because I'm doing so much. But just to reiterate, the first step was move the constant over. The second thing was take this number here, divide it by 2, and square it, and that's where I got the 9, and added that to both sides. Now here, I'm going to take the square root of both sides, and that's why it's so convenient to have that binomial squared, because now I can take the square root of both sides. And what ends up happening is that cancels with the squared. I get x plus 3 equals, remember if we take the square root, we do the plus or minus. And the square root of 12, I'm not going to show you how to get this right now, but it's 2 root 3, and you can even plug that in the calculator. And then the last thing is subtract 3 from both sides. So x equals negative 3 plus or minus 2 root 3. Alright, now again, I'm going to do another example. If this doesn't make sense, watch the next video, but I wanted to kind of go through what it means to complete the square. But now the next one, I'm just going to show you how to do it. I'm not going to go through all these explanations. I know this is, again, kind of convoluted and a little bit messy. Hopefully the next video will help out a little bit.